Just to see here, current carrying conductor is having magnetic field around it. This is the meaning. Okay. This field, magnetic field, it is denoted by B. And current is passing through a conductor, straight conductor. So that current is, we know that is denoted by I. At present, these two are noted down. Next, one more point is there that we will discuss in next step. See, current carrying conductor creates two properties. One is magnetic field around it. Second one is exert a force on current carrying conductor. This is the third one. Third property we know. That means three properties you can see in current carrying a conductor. So one is magnetic field, second one is current, and third one is force. So is there any practical applications by using these three parameters? So one by one we will see how magnet is behaving or magnetic field is behaving. That we will see one by one. See, first you see straight conductor. Straight conductor means a single wire. It is carrying a electricity. It is carrying a electricity. That means it is having magnetic field around it. Okay. This is the meaning of straight conductor carrying a current. Okay. So next one is circular loop. Circular loop, just you see here, whenever bend is there, whenever bend you see, that behaves like a magnet. That behaves like a magnet. Just you see, magnetic lines are emerging from this side and entering from this side. And you are seeing magnetic lines are entering from this side and moving this side. That means here you can see that one north pole, one south pole, one north, one south. That means these ends behaves like a magnet. And also properties you see, center it is straight line. It is straight line. Here concentric circles are more. If you go outside, they become less but become wide or bigger. Okay. Now solenoid you see. Solenoid here it is a circular. It is circular loop. That means it is circular. And here you see. Here they have, what is solenoid? That we will see first. See, a coil of many circular turns of insulated copper wire wrapped closely in the shape of cylinder is called solenoid. Just you see, here you can see the circular turns. Okay, and it is a color also you can observe. This is a copper wire wrapped closely in the shape of cylinder is called solenoid. And pattern you see, current, see, battery we have connected here, one plug is there, it is connected to power. Now you see the magnetic field. Magnetic field you see, we close this circle. See, all lines are concentrated at one place. All lines are concentrated at one place. So now one by one we will see. See, this bent portion behaves on magnet and this bent portion behaves on magnet. See, now you complete these circles. See, figure you will get like this. So that means center, you see, center again straight line. Okay, and these field lines you see, field lines are concentrated more in the center. That is very, very important. So magnetic field lines are more concentrated at the center. This is very, very important property of solenoid. Magnetic field around a straight conductor carrying by current. It is given by a right hand thumb rule. Right hand thumb rule. Oh, so what right hand thumb rule is telling? See, this is the conductor carrying a current, and if you put your hand like this thumb indicates the current, direction of current. So around this you can observe that magnetic field. Just you see this line is perpendicular to magnetic field. Now we will see what is perpendicular. Perpendicular means if you draw a graph, x-axis and y-axis, if this angle is 90 degree, it is called perpendicular. That means these two current carrying conductor and magnetic field are perpendicular each other. Okay. And carefully you see, straight conductor carrying current, the rule it is given by right hand thumb rule. Very, very important. They may ask questions on this. And depends on magnitude of the current. This magnetic field depends on magnitude of the current. That means what? B is directly proportional to I. Suppose if you increase the current, magnetic field will increase. That is the meaning. And distance, if you increase the distance, so that means B is inversely proportional to 1 by D. Suppose if you increase the distance, magnetic field will reduce. That is the meaning. So one thing you have to remember, right hand thumb rule is very, very important. They may ask question on this. It is concerned only for straight conductor. Don't confuse. Okay. Now here you see, here one right straight conductor, what we have seen, one right hand thumb rule, and second one is conductor and a magnetic field is perpendicular each other. 2 points we have seen. Okay. Now circular loop we will see. See, this bent portion behaves one magnet, and this bent portion behaves one magnet, and here you see concentration of circles is more, and if you go, it will become wide and large, and center it will become straight line. So this they may ask question, in the examination. Center almost it is straight line. Two magnets are there, here one magnet, and here the ends it is very concentrated circles. If you go to the center, it will become straight line. So for this some practical applications are there, but it is not discussed in your textbook. So now magnetic field larger and larger as we move away from the wire. So magnetic field lines larger and larger. Larger as we move away from the wire. Away from the wire. And by the time we reach at the center. At the center, big circles appear. As straight lines. See, this they may ask in examination. So, see, magnetic field depends on current. That means B is directly proportional to I. If number of turns and also number of turns and the radius of the coil, current and the number of turns and radius of the coil. Okay. Next one is solenoid. Solenoid, you see number of circles. It is just like wrapped like this, and it is connected to battery. It is connected to battery. So already this I explained. For points we will see. Magnetic field lines parallel straight lines inside the solenoid. See, these lines you see, they are parallel. Magnetic field lines are parallel inside solenoid. So this they may ask in examination. Very, very important. MFL means magnetic field lines. Magnetic field same at all point inside the solenoid. Inside the solenoid you see magnetic field same. Magnetic field same at all points. At all points inside the solenoid. Inside the solenoid. So then how it is depending? So it is depending on current. Magnetic field is depend on current, and number of turns and radius of the coil and radius of the coil. Then is there any practical application with this solenoid? Yes, practical application is there, that is making permanent magnet, that is electromagnet. So solenoid property is used for making electromagnet or permanent magnet. So this is the property used to make from solenoid. So one property we have seen, but solenoid we can use it for our daily need. So next one is exert a force on current carrying conductor. See, just you see, this is the conductor, it carrying a current. So one field you can observe, that is perpendicular, and one more force you can see, force. 3 parameters you can see. One is current, second one is magnetic field, and third one is force. Okay. These three, if you plot in a graph, so you can observe like this. This is x-axis and this is y-axis. One more axis, z-axis. See, these three are perpendicular each other. 90, 90, 90. So these three parameters are perpendicular each other. Is there any practical applications by using these three parameters? We will see one by one. So here it depends on current and magnetic field and theta, sin theta. That means angle. Okay. So it is given by Fleming's. It has given a Fleming. He has explained a Fleming called Fleming's left hand rule. This is called Fleming's left hand rule. Here you see, don't confuse. Exert a force on current carrying conductor. So that means three parameters: current, magnetic field, force. It is given by Fleming's left hand rule. And straight conductor, it is a right hand thumb rule. Okay, don't confuse. Is there any practical applications by using these three parameters? Yes. One is electric motor. What is electric motor? Then the question will come, which converts electrical energy into mechanical energy. Next we will see. And electromagnetic induction. Second one, electromagnetic induction. So that means changing magnetic field in a conductor induces a current in another conductor. That one application that we will discuss in coming sections. So third application is electric generator. So electric generator, again question will come. Mechanical energy is converted mechanical energy is converted into electrical energy. That means mechanical energy is used to rotate a conductor in a magnetic field to produce electricity. And also you can say that number of applications you note down, because they may ask questions on this. Loudspeakers. Loudspeakers. So next, microphones. Microphones and measuring instruments. These are all the practical applications.